to come to this session at 5 o'clock, so way to go, guys. Thanks for coming to my session. My name is Rui Maximo. I'm a principal content architect, and I'm here to talk about the Edge server on Lync server. How many of you have actually deployed the Lync server? Oh, quite a few. That's great. Well, congratulations. I have a bunch of giveaways here, so I need to make sure I give those away. So if I don't give them away, please remind me, all right? So that's great. I'm glad to see that there's a lot of adoption of Lync server. It's great. One of the things that we want to make sure that you have at your disposal is the information you need to deploy, plan it out, troubleshoot, monitor your any issues you have with Lync server. And one of the things that we've created is Lync, the NextHop community. And if there's only one URL you have to remember, it's just basically nexthop.info, and it's basically a redirect. That's all it is. It's a redirect to TechNet, and it'll take you to the TechNet community. So how many of you are familiar with the Exchange Hello blog site? Yeah, quite a few. So basically, NextHop is the equivalent of the Hello for Lync. So if you want to find any information about it, you can go to NextHop, and you'll find a bunch of things like, we aim to foster the Lync community. We have a blog role there, so if any of you blog about Lync and have some really good content, let us know, because we'll be sure to put on the blog roll so that other folks can come and see the information that you have to offer. So we're not just providing content, but we'll also encourage other folks like yourselves to go and blog about Lync and make it visible. Other things that we do as well is we listen to customers. So we have a documentation feedback alias, linkdoc@microsoft.com. And that's an opportunity for you, whenever you go and read through it and find some issues, you can provide some feedback and email it to us. Another alias you can do that's specific to the articles on NextHop is nexthop@microsoft.com. In fact, we're really blessed to have Patricia Anderson here. She's sitting in the audience, and I'll have her come. Trish, if you don't mind standing up for a second. She's our documentation manager. So if you have any gripes or any requests for documentation, please bring it to her. She wants to hear it all. She came here specifically for that. So please, don't be shy about doing that. We'd love to hear from you. In fact, that's one of the things we want to do is we want to be able to stimulate a dialogue with you. Right? So we have a tweet, which is twitter.com/drrez. Unfortunately, he's not here today. I was asked to take his role as presenter today. But we also have a Facebook page, so you can also go there. So there's a multitude of ways for you to be able to join us. You can see on the top right-hand corner here, we have a Microsoft tag. So if you want to picture that, that will take you straight to nexthop.info. So it's a good thing. Here we have the banners for NextHop. Dr. Rez. Dr. Rez is basically for all the authors of the Resource Kit book. Are any of you familiar with the Lync or the Resource Kit book for Office Communication Server? Some raised hands. All right, a few. Well, that's basically the authoritative source for inside information about the product. In fact, we're going to come out with the new version for Lync Server 2010. It'll be out sometime this summer. We already have. We're doing a different way of publishing it. Instead of just having one book that comes out, what we're doing is we're already pushing out the chapters online on the internet, and you can find them on Dr. Rez. So go ahead and take a look. You can download the chapters. You can start reading them, and it's an opportunity to start a dialogue. So if you find any issues in the interim between now and until we get it published, we'd love to hear from you guys so we can make sure we get those corrected before it goes into print. And so we're using some different models here. We're going to do some ebook printing as well as hard copy printing on demand. And then last but not least is the Lync Server 2010 PowerShell. It's a really fun blog where you can find anything about PowerShell on Lync. There's all kinds of fun games and tips. For example, if you want to be able to map what the commands are or the PowerShell commands are to the UI, it gives you that information. So anything you want to know about PowerShell in Lync, that's a blog you want to go check out. So, of course, why do we have these properties, web properties? Well, it's really there to educate and inform you. So we have the Tech Center homepage that will give you all the information and technical library for all the product documentation. We even have some videos, the first run videos that helps you just get started. They're 5-minute videos or less. So we're really not trying to get you to sit there for like an hour. But just to get you started. It's really just to get you started going and understand how the product works and what to do next, because it can be pretty overwhelming for those who haven't deployed it, what to do, what the first step should be. And then we have the Visio protocol flow poster, which you see here. There's a link, and you can find it on Dr. Rez as well. In fact, let me show that to you guys. So if I were to type, and I've pre-populated this already, but if you were to type nexthop.info, it would bring you to this technet.microsoft.com page. The URL is a little long, so that's why we created the short redirect. But you can see it's a community here. There's all the blogs that I just mentioned, NextHop, Dr. Rez, Lync PowerShell. The Lync team blog, that's for the client side. So anything that's non-IT pro, that would go into the Lync team blog. And then the UC team blog as well, that's where you get good resources straight from the team. And then the UC Dev Center for the developers. And then you have contributors. So if any of you are interested in contributing articles for NextHop, please let us know, because you can, we're always encouraging folks to do that. We'd love to hear from you guys. And those links are there. So then if you were to click on Dr. Rez, it'll take you to this page here, which you'll see. And that's his nice mug there. And there's a bunch of articles you can see over here: troubleshooting basics, conferencing collaboration. And those are released on a monthly basis. It can vary from 4 up to 20 sometimes in a month. So there's a lot of contribution. And they get specific. One of the things we're making sure is that these articles are published on the web, so it's easy for you to search. You could just use your favorite search engine, whether it be Bing, of course, right? And hopefully find these articles based either on author or some of the keywords. And then if you were to click over here, you can see the Lync Server 2010 workload poster, and that would take you to this page over here. And the nice thing about this is, let me show you here, is I can increase it, and you can span it and move around and see the different aspects of it, so you can get really close to it. So this poster here is really meant to have a bird's eye view of how everything kind of works, so based on the modality. So as you know, Lync supports IM, AV, and web conferencing, as well as voice, and application sharing. So if you only want to deploy certain aspects of it, then you can just look at what the call flows would look like for that particular modality. All right. So let's play some trivia here. This one's going to be an easy one. Anybody know what an edge server is for? First one to raise their hand, please. Oh, gentleman there. Say that again, please.
For getting people access outside of your internal network.
That's exactly right. Please come on up. You got a nice camera here. Ultra-thin mobile design. Please, a hand of applause here, please. Thank you. Yes, that's exactly right. So the edge server is there to help you deploy, to give you access of the features that Lync provides external to your network, right? So let's go back here. Go back. So it gives basically the external users access from outside. I mean, it's great to have all this functionality to do collaboration and to do conferencing and to make calls without having to be in the conference room. But it doesn't really help if you can't do it from outside your corporate network, right? Because it always happens. There's something that comes up. You got to stay home. There's a sick kid. But you still want to be able to contribute and participate with your team and get work done. So this is a great way, using the edge server, to connect back to your network and be as if you were in the office. So that's what the edge server provides, is external user access. It's just transparent connection to the edge server without having to do a VPN necessarily, and you can do it anywhere from the public network. Another aspect that you can use the edge server for is PIC. It's public IM connectivity. So you can connect to MSN, the cloud, AOL, and Yahoo networks. So you could talk to folks who are on Windows Messenger, for example, and have a dialogue with them and even talk. Another aspect you can do is federation. So, for example, if I'm Contoso.com and you, sir, are Fabricom.com, your employees can talk to my users because we have a federation connection there without having to set things up. Right? All right. So this table here provides a quick snapshot of the edge-supported scenarios. So presence, it's supported in remote user access, federation, and PIC interoperability. You don't do it for anonymous users because they're anonymous. They don't have a corporate credential in your network, so you're not going to look at their presence. They don't have a specific count. You can do IM peer-to-peer for all three, federation, remote access, and PIC. You can do IM conferencing, and here you can do it for remote user, federation, and anonymous users. So anonymous users, you can invite, say, a partner or a customer to your IM conference without them having to have an account. That's what it means to be anonymous and still participate there. Collaboration, same thing. And then AV peer-to-peer, you can do it with remote user access as well as federation and with PIC with the latest version of Windows Messenger. AV conferencing, so that would be remote user, federation, and anonymous. And file transfer, you can only do it with remote users and federated users. Okay. So traversing NATs, why should I care? Well, probably want to care because a lot of people have it, right? Everywhere on the network, even at your home, you probably have a router and it's doing NAT. Corporations, small, will do a lot of NAT, bigger ones as well. They'll have firewalls. The internet is full of them, right? So why do you need to care? Well, because if you want to be able to do AV communications and set up an AV session, then you need to be able to traverse these NATs. So that's what let's talk about how that works. So some terms and some acronyms here to understand. Well, actually, I just showed this, but anybody know what NAT means? Please, sir, in the back.
Network address translation.
That's very good. Thank you, sir. And a round of applause for this gentleman, please. Thank you. And another fabulous camera. Woo! I'm reserving the big prize. It's called bacon toothpaste. Very nice. All right, very good. In addition to NAT, so we have candidates. What we call candidates are basically possible combinations of IP addresses and ports for media channels. And I'll talk a little bit more about what that means. NAT, network address translation. TURN is a protocol. It's traversal using relay for NAT. STUN was simple traversal of UDP through NAT. It's now called session traversal utilities for NAT. And we'll see how those come into play for establishing AV sessions. So home NATs. We talked a little bit of routers, for example, at home. You get your wireless router or just a regular router. And in general, NATs and firewalls behave. What do they try to do is they basically block you from having access, right? The whole point is to protect your internal network. So it allows connections from the private network outbound, but it blocks connections from the internet. It's for protection. It also does scalability and security and usability trade-offs. So it blocks the attackers from harming your system, which is good. But the converse of that is that, the problem is that it also blocks incoming signaling and media. So if somebody's trying to call you, that signal is going to be blocked because it can't get past your firewall. So we need to find a solution for that. For corporations, it's similar, though it's more scrutinized. The goals are similar here. Usually corporations will have 2, maybe 3 firewalls in between their servers. They'll have this network perimeter where they have the servers that are only accessible from the internet, but in front of that will be a firewall. They call the outer firewall. And you'll have an internal firewall as well. So here you want to also be able to share IP addresses and allow traffic to flow, at least the authorized traffic to be able to flow. So in this case, you'd use 2 firewalls to isolate the perimeter network. And here you can see that with the 2 firewalls, you can get out, but if you're from the internet, you won't be able to get in. And sometimes if you're on the inside, you won't be able to get out if you're not using specific ports, if a lot of the ports are closed. So why is NAT traversal the problem? Well, because it blocks your AV sessions from being established. All right. By the way, one thing I forgot to mention is a lot of folks who actually contribute and help us out on nexthop.com are MVPs, and also the MCTs, the Microsoft Certified Masters, and I see a couple over here. And they're sporting nice shirts. I just wore mine. You get some nice gear if you become an MCM, and a nice bag and all that stuff. It's a really cool program. I should put in a plug in there. I have a bunch of giveaways here for you if you'd like to come up later on. And you can go down to the booth and win a prize. So it's pretty cool. So a little bit about the program. Lync server is certified. So if you want to become a certified masters, it's about a 3-week program. And it goes through a pretty grueling process. I mean, you really learn about everything about the product and how it works. I mean, these guys, they're masters. What can I say, right? So that's my plug. All right, so signaling. SIP signaling over TCP uses the access edge. So what that means is for the signaling part of it, the edge server is basically comprised of 3 components: the access edge, the web conferencing edge, and then the AV edge. So for the signaling part, it goes through the access edge, and you have the invite, and the port has to be open, and so you get the invite, you do a 200 OK, and you're good to go. The UDP media flow flows over a separate channel. So the actual the audio signal goes through a different channel. And usually we want to use UDP. By the way, anybody know why we want to use UDP for audio, for the media? Sir? Because we don't have time to wait for an answer. It's connectionless. Yes, absolutely, because if I'm talking, forget about the packet that I just lost there. I already moved on, and I just want to hear the next part, right? Exactly. Well, sir, very good. You got a gift here. Please, a round of applause for this gentleman.
I really need an IP phone for my lab.
Oh, you want the IP phone?
I got one of those. Yeah.
Oh, you got one of those?
Yeah.
I have,
Single free line, so I have to buy this.
Oh, well, okay. Well, I'll give you this if you want it.
Yeah.
And then you can try to win that one, and I'll trade you for that if you answer fast. So for those of you who don't know what inside is inside this box, it's an IP phone. It's a 10J phone. It's really nice. Excuse me. I thought I put it on mute. So it's a really nice phone. I'm leaving that for the last. The best for the last, right? But no, well, maybe not for the last. This is really cool. Come on. Maybe I'll keep it for myself. All right, so for endpoints, for the media to flow, we need pre-ICE endpoints use the local IP and ports. So if you don't have ICE configured clients, or if you don't use ICE, then the media can't flow because it just gets blocked with all the firewalls in between. If you're at work and you're trying to get through, then you're going to hit the user that's at home, and you're going to be blocked by their NAT firewall. And if you're at home, you're going to be blocked by the corporate firewall. So it's just not going to work. So the solution here is stun, turn, and ICE. So it's those 3 protocols, and they work together, and they make this make it possible. So what happens here is, in addition to the edge server, you have a media relay, which is basically called the AV edge service, basically. We don't call it the server anymore, but we call it the service. But it can be thought of it like that way. So what happens here is basically stun is like looking at a mirror, right? So it just tells you what your public IP address looks like, because you have your IP address, which here in this case would be A. That's your home address, and you know what it is. But you don't really know what IP address you appear as from your NAT. And that would be B and E. We have B and E because one is going to be UDP, and then the other one is going to be TCP. Okay? So stun helps you look like it helps as a mirror and says, hey, here are your B and E IP addresses. So that way you can advertise them. And likewise, on the work side, you have an IP address, which would be W. So turn relays the media packets C, D, X, and Y. And what that does there is the IP address W on the work side is private. So that means that the user at home is not going to be able to access, not going to be able to connect to that particular IP address. What it does is with the stun server, or the stun part of the server, is it publishes or opens up these ports for the work user. Right? So it opens up the ports C, D, X, and Y. That way, and it transmits those connections, those IP addresses as candidates. So ICE provides the exchange mechanism for the candidates and determines the optimal media path. So basically, it shows that across the two clients. And all three protocols are based on IETF standards. All right. So what reference architectures can I use for the edge server? How would I go and deploy this? Well, there's three options here. One is with the edge with single IP address. You have the edge with multiple IP addresses. And you have the edge with NATed IP addresses. So in a single IP address configuration, you can basically just use one IP address on both sides. Now, this was an improvement, if you will, over the previous version, which was Office Communication Server 2007 R2, or 2007, where it actually required you to have 3 IP addresses, or at a very minimum, 2 IP addresses. So it was really difficult because maybe you don't want to have to publish so many IP addresses to the internet. So here it really simplifies it for you, so you can just have one IP address and you publish it. You have less of an exposure to the internet because you have less IP addresses that you have to manage and protect against. And so this external IP address, we would call edge.contoso.com, can have one specific IP address, and the different media flows will be based on the different ports. So SIP would go over port 5061, and that would be secured SIP. Web conferencing would go over port 444, and the AV conferencing would go over port 443 as well as 3478. Then on the internal edge, so you really need to have an edge server with minimum of 2 NICs, right? On the internal, you have an FQDN of edge-internal.contoso.com with a specific IP address. Preferably, highly recommend to have it on a separate subnet. And again, here you would use port 5061 for SIP. That's the signaling aspect. And then for web conferencing, it would be port 8057. And AV conferencing, the same one as the external, would be 443 and 3478. So you have to specifically specify that you are using a single IP address in FQDN for this configuration. The default configuration would be 3 IP addresses on the external side. So the internal NIC, you'd have the same configuration, but on the external side, you'd have 3 IP addresses, and one for the access, one for the web conferencing, and one for the AV. And each one of those IP addresses would have their own separate FQDNs as well. And again, here the ports would be different. Notice that in all 3 cases, you have port 443 that you can use. So that's nice because if you are at a corporate site, at a customer site, and they only have 443 open, for example, then this is a way for you to be able to access it because they only have that port accessible. So edge with a NATed IP address. So it's possible to have 3 IP addresses and still NAT that so that you have a level of protection on the public IP space. So IP1 prime maps to IP1, IP2 prime maps to IP2, etc. In this case, the client connects to the IP for AV traffic. So they would connect to IP3 prime, and you need to be able to translate that AV IP address you need to configure that in the Lync server. So the translation of IP3 prime to IP3 needs to be configured there. So there's the clear mapping. And the Lync server doesn't need to know the translates IP addresses for SIP or web conferencing. So it doesn't need to be aware of it. But only for the AV conferencing does it need to have that mapping. The reason it needs to, again, is for the case of ICE, to establish the connection, right? So it needs to know what that IP address is so it can advertise it when it sends it to clients who need to be able to connect to it. All right. So next is load balancing options. There's some new load balancing options that we have. Yes, sir.
I understand the version before on 12 and 13 why we had to use certain types, but what dictates a deployment to use a single IP, multiple NAT IP, or multiple multi IP?
That's good. So the question was, what drives the decision for using a NATed IP address, a single IP address, or multiple IP addresses?
Except the 4434 being the only thing allowed, but other than that, it seems like if the ports aren't a problem, obviously single IP will be perfect. Is that where you're going with load balancing later on? Is that going to affect it, or what would make us decide one versus the other?
That's a good question. So let me see here. So for load balancing, there's a lot of different options as to why you'd want to choose, NATed IP address, a single IP address versus 3 IP addresses. One is, like I mentioned, is management. You don't want to have to manage 3 IP addresses. You want to, cut down the number of exposure. So instead of having 3 to manage, you have just a single one. Another reason possibly is if you want to separate the for load balancing. So with load balancing, when you use a hardware load balancer, you can have a single IP address for VIP, and so you can separate out the channels more. There's a lot of different options. I don't necessarily know why customers pick one versus the other, but you can also go down to the booth, and there's some other folks there that can help you and give you some answers there. I don't have a good understanding as to why people pick one versus the other. I personally like the NATed one because it's simpler. But again, my environment is smaller. I'm just one server, so so it works well, especially for small environments. Okay, but yeah, I encourage you to go down to the booth. It's right next to the Exchange booth, and we have lots of giveaways. Yeah, and we can also take it after the session. We have Peter, who is from the product team, and he can help answer that question too. Thank you. So load balancing. So we can, with Lync Server 2010, yes, ma'am? Can the edge server be inside the DMZ? Yeah. Oh, you mean, yes, absolutely. It needs to be inside the DMZ. Yes, if I wasn't clear about that, I apologize. Yes, we don't call it DMZ, we call it the network perimeter, just because of the political implications. But yes, absolutely, you want to deploy the edge server in the network perimeter. Yeah, not inside your corporate network, but inside the network perimeter. Yeah. Good question. All right. So in this case, we have support for DNS load balancing. So you don't have to deploy hardware load balancer. You can if you choose to, and the option is still there. But we also now support DNS load balancing just to help simplify, based on customer feedback who've said, it's a bit expensive for those hardware load balancers, or it's just complex. Whatever the reason may be, we've added the support for DNS load balancing in Lync Server 2010. So in this case, you would have to publish, you publish these records in DNS, and for the access contoso.com, for the access FQDN, you'd publish IP address 1 and 4, because that would be the corresponding IP addresses for the access edge on the 2 edge servers. Conversely, for the web conferencing, you would publish IP address 2 and 5, and the AV, you'd publish IP address 3 and 6. Right? So when you publish these IP addresses and the client requests and makes a DNS query, it'll get back, for example, for the access edge, it'll get back IP address 1 and 4. And so it can pick whichever one to go. And let's say if the edge server 1 was down, it would try, and then when it sees it fails, it would go and pick the next one, which in this case would be IP4. Okay. So that's what I'm saying is the client can retrieve and handle multiple IP addresses and can fail over. So if IP address 1 doesn't respond, then it just picks up the next one and goes from there. The DNS server returns the IP addresses in randomized format. So it's not like in a specific order. It'll just do that. And it's a nice way to actually just use the existing DNS infrastructure for doing load balancing. So here in this case, you can also use DNS load balancing edge using NAT. So you can NAT the IP addresses and have them. Yes, sir, question? The live meeting client. No, I don't believe it does. It's not right. Yeah. I have the expert here as well. The hardware load balancer for that? Yeah, so you want to keep it that because the client does. You have to have the client that performs the logic as well. Because if you return the IP addresses and you have 2 or 3, the client needs to be smart enough to say, oh, well, the first one failed, so I need to try the second one. And right now, the live meeting client doesn't have that logic to try the next one. It'll just keep trying the first one that it gets. Yeah. So in this case, with the NATed IP addresses, as the DNS A records that you would publish would be IP address 1 prime and IP address 4 prime for the access edge. You wouldn't be publishing the IP address 1, but the external one that's NATed for the access edge or conferencing and AV. And also, one of the things you have to do is you need to make sure that the translated the AV IP addresses must be configured in Lync server individually. So again, the Lync server needs to be aware that the IP3 IP address is really mapped to IP3 prime for Edge Server 1, and for Edge Server 2, that IP address 6 is mapped to IP6 prime because of the ICE negotiation that has to happen. So in terms of hardware load balancers, how many of you use hardware load balancers with your products? Okay, a good number of them. Great. So one of the things you can do that's nice with the hardware load balancer is you don't have to muck around with as much with DNS. You can use virtual IP addresses, and so you only expose 3 IP addresses. So if you have a client that doesn't understand how to fail over with a different IP address, a DNS entry, then you just use a hard load balancer. And so you just publish the VIPs for 1, 2, and 3, which map to, for example, for VIP 1, that would map to IP address 1 and IP address 4. And same thing for for VIP 2, it mapped to IP address 2 and IP address 5. Yes?
The rest of the documentation says you still need to publish the internal IPs, which have to be published as well. Is that correct?
Yes. Yes. Oh, could you repeat the question, please?
The internal IP 1 through 6 there, they still need to be public IPs.
So the question is, the internal IP addresses, IP1, 2, and 3, IP1 up to 6, do they need to still be published? The answer is yes. They still need to be published, yes.
Should only be 3 and 6.
Oh, you can use, so the comment here is you can use natting for those.
So let me take this one. Is there a mic up there?
No, but you can take this one.
Sorry. Okay, so sorry to jump in on this one. So basically, we support 2 buckets, right? The first one is that we do the DNS load balancing with the NATed IP addresses. So now in theory, what you can do is you could NAT all of this as well. It gets extremely complicated to configure and to set up. And the main reason is our, on the AV edge, the individual IP address of each edge server is the one that gets handed over to the client that's on the outside. So when the client does a negotiation request, it hits the VIP 3 in this example. It will go to the edge server. The AV edge will come back and say, here is my candidate of the IP address, which is either IP6 or IP3 in this example. So now you can say, well, I want to save on this. Let me just NAT the IP1 and IP2 and the IP4 and IP5. So is that, yes, you know, in theory, you can all make all sorts of permutations. You can actually make it work. However, we decided not to support all those permutations because it will be extremely difficult to actually make a combination right out of this one. So therefore, we said, okay, if you still use the hardware load balancer, just have the other ones not netted. I mean, you can also, of course, you can, although we don't have a graphic here, you can have a single IP address. So you don't have to have three. And then with a single IP address, then, of course, they have to be public as well. So I can, so after the session, I'm happy to answer those questions. There's some decisions that are basically made not of a technical reason, but just for supportability reason.
So you're saying that slide where it talked about if edge server having a single IP, you can still load balance that even though our edge servers are using one single IP for webcons access.
Yes. So the question is, what about with a single IP address? Yes, you can do exactly the same thing. So in this, you can translate this graphic as well and can say, hey, it's a single IP address that gets load balanced. I can talk in the end about the reason why folks want to choose 3 IP addresses versus 1.
Great, thank you, Peter. I can turn that off. Okay, we're back. Great, thank you. Any other questions on this particular topic? Okay. So that's the comment here, is that NAT and hard load balancers, you can't combine them together. It's just not possible. The complexity is there's a lot of complexity around that, as Peter mentioned. All right, so coexistence. So with DNS load balancing that's supported in Lync server, unfortunately it's not supported in the previous versions of Office Communication Server 2007 and R2. However, if you have a Office Communication Server 2007 or R2, one or the other, not the two coexisting together, with the pool and the edge server, then those can coexist with your Lync server pool and your Lync edge server. However, only one edge server or pool can be used for federation. So it'd either be the 2007 version or it'd be the Lync version that would be used for federation. For DNS load balancing, so when you have legacy components that do not support DNS load balancing, if your coexistence time is going to be short, then we recommend you can go ahead with DNS load balancing. But if your coexistence time is going to be longer, then you probably want to use hardware load balancing in the interim until you have completely migrated over to Lync server. Reverse proxies. So why do you need it? Well, your question, yeah, go ahead, please.
Well, the clients are coming in from 4.3, you can reverse that to 44.3 so they can get to the downloading the address book, doing different things that need to do with the client.
That's right. So the reverse proxy is basically used to tunnel or for all of the HTTP traffic, HTTPS and HTTP traffic. So it just goes through it, and then it translates that over to internal ports and IP addresses on your network. And a lot of companies use it. It's a very commonplace for this type of traffic, the web traffic. And so that's what we use it as well. For Lync server, as this gentleman was saying, it's used for URLs, for address book server, for the distribution list expansions, and also for web tickets. As well as the HTTP is used for client, for doing firmware updates, as well as logs, for uploading those logs as well. So, great. So the reverse proxy and external access. So in Lync server, we have simple URLs. Basically, it's the shortened URLs instead of the long ones that were used for conferencing. And you can either forward those URLs to the director from the reverse proxy, which is recommended here because it just makes it a single point of hop from the reverse proxy. So forwarding rules for simple URLs to a single director. And then the director will be responsible for distributing that request to the different pools. The reverse proxies, in this case, if you're doing that type of deployment, the reverse proxy certificate SAN, the subject alternate name, needs to contain the base FQDN of each of the simple URLs. Right? The reverse proxy also can forward web external pool traffic to each of the pools. In this case, the reverse proxy requires a forwarding rule for each one of the web external FQDNs for each of the front-end servers and directors, and it's used on port 443. If external phone devices are implemented, then the reverse proxy is going to use port 80 for for that functionality. And the reverse proxy certificate SAN needs to contain the base FQDN of all the configured external pools. So that becomes pretty long if you have different, well, if just the base FQDN. So you could have the same base FQDN, and that would work for all of them. So this is kind of like what it looked like pictorially. So if the client connects to the reverse proxy, and again, the reverse proxy here would be deployed in the network perimeter, and it would be accessing it from the outside. And for all the simple URLs like join.contoso.com or meet.fabricon.com, those would go directly to the director. And then if you have specific external pool URLs like web external 1 and web external 2, those would go to the corresponding pools there. And so we put that information in the SAN, in the reverse proxy certificates, so it's there. DNS load balancing is not supported for HTTPS traffic. So here, if you wanted to do DNS, if you wanted to do load balancing, you'd have to go with a hardware load balancer. But most likely, you guys already have that infrastructure set up if you already have a reverse proxy. So it's not something that would be new, hopefully, for your case. So authentication. So how do clients establish AV connections? So trivia question. So what are the authentication protocols does Lync server support for SAN? Yes, sir. I can't hear you. Kerberos and NTLM. That's a good answers. There's one additional one. Yes, sir, in the back. I'm sorry? I couldn't hear you. Oh, claim-based? Certificate, okay. What's the name of the protocol for that? SAML? Okay, TLS, DSK, right? So TLS, DSK is certificate-based. And you are a lucky winner of the nice T-shirt here that we have. Come on up here, sir. Big hand of applause. Who said TLS? Oh, was there? Okay. I got something else for you. You get a ticket for a prize. All right, here we go. So yes, TLS, DSK, and basically it's client certificate-based authentication. Thank you. So what actually happens is the client will go and request a certificate from the Lync server itself, and it's a self-signed certificate that's issued by the Lync server. And every subsequent login request by the client will be performed using that certificate. And it's a fairly, well, it's a short-lived certificate. It's about 6 months. And it is requested directly upon first log-on. Whether the client logs on initially using Kerberos or NTLM, and then requests that certificate. It's performed behind the scenes, so the user doesn't need to know. And once the client gets that certificate, which is stored in the My Store, the user's My Store, it's then subsequently used for authentication. So the way it works for AV authentication is every time you want to do an authorization or access for AV sessions, the endpoint on the outside needs to request the credentials. So it performs a SIP subscribe, and that's basically a login through the access edge. And then it returns a 200 OK, logged in, and it sends back a bunch of information like your in-band provisioning settings and configuration settings, and other information. And in addition to that, it also sends back a SIP URI of the media relay, which is your AV Edge service of the Edge server. Given that information, it goes in, the client issues a SIP service request and specifies its location being the internet. And that gives the indication to the user's front-end server to go and request authentication credentials from the media relay, which is named here MRAS, Media Relay Authentication Service on the AV Edge. So once it gets that information, it sends that back to the user, and it provides a bunch of information, like the host name. So it gives back the FQDN of the AV Edge on where to connect, the ports on which it can connect to the AV Edge, and then the username and password and how long those credentials are good for. So given that information now, the endpoint can connect directly to the AV Edge server and establish a AV session. So similarly for getting credentials for a conference, and this is for every specific session that the client would do this, it'd go and log in, do a SIP invite, or I'm sorry, assuming that the user is already logged in, do a SIP invite to join the conference. The front-end server then contacts the AV MCU or the AV Edge server, I'm sorry, the AV conferencing server, and using the C3 protocol, there's a typo there, it tells the conference to add the user. The AV conferencing server, the MCU, goes and talks to the MRAS, the authentication service in the AV Edge, to request credentials, which it gets back, and sends it back to the user's front-end server with the MRAS credentials. And that is sent back to the user's client. So again, you get the FQDN, the ports, the user credentials, username, password, and then the duration of how long that is. And so at that point now, the user can connect to the session, the conferencing session over for AV. So with the Edge server being directly or slightly behind the firewall, you want to be able to protect it. A lot of times you'll run into your security team, and they're like, oh, you want to put an Edge server in my network perimeter? Oh, no, forget about it. That's not going to happen. So you really have to go and educate them about what it does and how it does and how you can protect it and work with them so that you can actually get that deployed. Have any of you had that type of problem? You've actually had to work and... You, sir? Yes? Right. Absolutely. That's another problem, is getting them to open up ports. And that's difficult. You have to really come up with a lot of justification for all those things. So I can see there's some of you that sympathize and have gone through the problem yourselves. So a lot of the questions is, well, how can I secure my Edge server? Because that's what they'll want to know. And so here's some information that can help you communicate back to them how you can protect your Edge servers. So some tips. So you want to use different subnets, particularly for the internal edge and the external edge, as we talked about. Right? You don't want to allow loopbacks. It's going to put you in a whirl of hurt there. So if I have a client here and I'm on the internal network, I don't want to allow the ability to connect directly from the internal network to the external edge of my Edge server. That's just going to cause a lot of problems. The user internally needs to connect to the internal NIC of the Edge server, and vice versa, of course. But that goes without saying that the external user would not be able to connect to the internal NIC of the Edge server. So you really want to make sure that it's clear there that the internal user cannot connect directly to the Edge server, and that creates a loopback, causes a lot of problems, and it's difficult to troubleshoot those kinds of issues. You want to lock down the routing rules for access to that subnet, disable broadcast, multicast, traffic to other perimeter network subnets. That helps keep things nice and tidy. Of course, you want to sandwich your Edge server between two firewalls. You've got an internal firewall and an external firewall. Put that there. We have a great guide called the Lync Server 2010 Security Guide. I recommend go ahead and leverage that. There's a lot of good information and recommendations on how to use that. It's something that's nicely packaged, so you can take that directly to your security team and say, here you go, we got something there. Last but not least is also, read and use the information in the protecting the Edge server against denial of service attacks and password brute force attacks. I know a lot of companies are worried about that. We've all heard of, Sony is a problem, and we want to be able to avoid those kinds of issues. So you want to be able to protect against those kinds of problems. With TLS DSK, supported in the Edge server, a lot of that problem goes away because it's a client certificate base, so you don't use passwords. You can, however, make that protocol fall back to NTLM, and then in that case, you'd be username and password. So there's a lot of work that's been put into a Lync server. Everything is encrypted, right? SIP is encrypted. The media traffic is all encrypted, so it's fully secured. But you always have, some companies like to have an additional level of security, and so there is a filter there that's available on the edge server to help protect against denial of service attacks. So one of the things that's difficult about denial of service attacks is that you don't know whether it's a legitimate, the attack looks like it's a legitimate request to log in, right? The problem is that it just starts consuming all your resources. So you're going in and you're trying to connect, and so it's using up all your resources, and so your internal servers are being used up to service these requests. And so this filter at the edge server helps block that right at the edge server. So even if there's a denial of service attack that's occurring on your edge server, it'll block it at the edge, and that way your resources internally are not affected by that. It could be possible that your edge server goes down, but at least your internal resources are still safe and sound. So definitely take a look at that. There's links embedded into this PowerPoint, and it'll be available for you, so you don't worry about wondering where to find that. Of course, you can find this article as well on NextHop. It's published there as well. It's available for the Office Communication Server 2007 R2 as well as Lync server. So things to know about securing communication server. So can someone sniff the packets that I'm using? Well, no. That's what I was mentioning, is that the server-to-server communication is performed over MTLS. That's mutual TLS, and then client-to-server is TLS. Instant messaging in presence, again, TLS is used. If configured, you could turn it off, but definitely not recommended for you to do that. Audio and video and desktop sharing of media is over SRTP. Trivia question. What does SRTP stand for? Yes, sir. Okay, what's the S for? Okay, that's RTP. SRTP. Very good, and you are the lucky winner of the bacon toothpaste. Come on, grab it, please. Well done. Are you sure you want it? Because I'll take it if you don't want it. That's right. Better than nothing. Desktop sharing uses TLS. Desktop sharing is over TCP because it uses the RDP protocol. Web conferencing is over TLS as well. And then any of the HTTP requests, whether it be meeting content download, address book server, distribution lists, expansions, it's all done over secure HTTP. It's HTTPS. So everything you can see, whatever the protocol we use, is secured. All right, so I talked a little about the Lync server security filter, but I wanted to give you a little bit more information about how it works. So what exactly does it do? It's an SPL script and a .NET service that runs on the edge server. Okay, so it must be registered, and you register it using PowerShell. And then what it does is it intercepts all remote user sign-in requests and responses. So basically, if you got a sign-in request, it goes in and it forwards it. The edge server will forward over to the director if it's the next hop or the pool, and the pool or director will be responsible for authenticating the user, verifying that yes, indeed, it is an accurate user. If the response was, if the password was incorrect or the information was incorrect, the edge server filter will increment the count because it'll look at the incoming packet, the request, and it'll look at the corresponding outgoing packet. Based on the call ID, and it'll map it. And so we'll see, oh, this request was for, this response was for that request, and the response was unauthorized, so that the user failed to log in. If your lockout count is 2, then the second request comes in, and then it gets locked out, and your count goes up to 2. So at the next time it tries to request, it just blocks it right at the edge server because the number of attempts that you're allowed were 2, and you've gone over that number. So you got denied right at the edge server instead of having to go once more connecting to the director. Yes, sir? So the question is it configurable in what sense? Oh, yes. So is the lockout count configurable in the lockout time? Yes, absolutely. It's configurable. You can set it to whatever value you want. Preferably, you want to set it to something less or identical to what you're using as the Active Directory lockout. Right? It works very similar to that way. Question? I couldn't hear. Sorry.
What happens if the user is also logging in using his AD credentials, i.e. Kerberos or the NTLM logins? Does this come into effect as well?
Well, so this is for the edge server. So when you're connecting from the external, you don't use Kerberos. It doesn't use Kerberos. It either uses NTLM or uses TLS DSK. And the edge server will monitor for those two authentication methods. Basically, it will go intercept the request during the handshake exchange. And in the case of the TLS DSK authentication, it'll extract the client certificate and read out the subject name from it so it can identify uniquely the user. And if it's in the case of NTLM, it'll actually get the user's credentials. So if it's Contoso/John, but not the password, of course, because it's not available. But that's how it uniquely identifies the user, because you can't spoof. You can try to use a different SIP URI and different credentials, and so we capture the unique part of it, which is the credential aspect. All right. Any other questions? No? So what does it do? It basically cracks the NTLM and TLS DSK authentication package, the SIP requests, and it extracts a unique identifier from the authentication package. So in the case of TLS DSK, it extracts the client certificate. In the case of NTLM authentication, it'll extract the username, just a username and domain name, right? And that's how it uniquely identifies the user. And then it'll track the number of failed sign-in attempts, which is the SIP response there. And if the number of failed sign-in attempts exceeds the threshold, then all subsequent requests are blocked right at the edge server for the duration of the timeout period, and then it gets reset. So what are some of the things you want to do is you want to be able to exclude some of the services that Lync services that run so that your antivirus program doesn't keep alerting you. And so I've given a list here of the services, the directories as well. I'm not going to go through all of them because it would bore you to death, I'm sure. But I wanted to make that available. And again, some more services and processes on the IIS and SQL side that you would want to exclude from your antivirus so it doesn't prompt you. One of the things also to help you out with your edge server configuration is the edge validation. So we have a tool that's available. It's publicly available on the web. You just go to testocsconnectivity.com, and it supports both R2 as well as Lync server. And it just checks to see the public web service, the edge. It just validates your edge server connectivity from the outside. It's a useful tool to give you some information as well. So address discovery. So we talked about candidates, stun, turn, and ICE. And so how do we establish a connection across the firewall? So in address discovery, when you're trying to discover which other's IP addresses that you can connect to, there's a whole process that happens here. And one of the things that helps is the media relay. So in the case of the endpoint, it knows what its IP address is, and that's the NIC over here, IP address A. And then it'll go and talk to the media relay and find out what address B is, which is your NATed IP address. And then the media relay will also establish a port specifically for your connection there. And so it'll collect candidates A, B, and C. And these are called candidates. We talked about the candidate list. And so those are the IP addresses that it can advertise to the other user. Those A, B, and C would be allocated for the UDP transport. Similarly, for TCP, it would go and establish D and E. as candidates. By default, we'd use candidate C, which is the UDP port on the media relay. And that would be the default port that would be used. For desktop sharing, because desktop sharing only uses TCP and not UDP, in this case, you'd get the IP address, the physical IP address of the client, which is A, and then you would allocate TCP ports C on the media relay and discover what IP address B is that is visible from your NAT. So your IP addresses would be A, B, and C. And again, here, your default candidate would be C, the one established at the media relay, which is the AV edge. In the case of an address exchange, when you have two endpoints across NATs, you have candidate on the left side, the endpoint on the left side, which have the candidates A, B, C, and D, which is their stun server, which is the AV edge server. And then on the right-hand side, so when the endpoint on the left side tries to establish a connection with the endpoint on the right-hand side, it'll go in the SIP invite, transmit its candidates that it has. So it'd be C, which is the default, but it also transmits A, B, C, and D. So that way, the endpoint on the right-hand side is aware of which candidates it could try to establish a connection with. On the endpoint on the right-hand side, it discovers what candidates it has, which is W, which is the physical network IP address, and then X, which is the NATed IP address, and then Y and Z, which are the established ports and IP addresses established by its own AV edge server. So in the response, the client that's the callee, the endpoint on the right-hand side, is going to send back a 183 session progress. And so while it's starting to ring the user's endpoint, it's going to start establishing connections, a session with the endpoint. Because in the case of a voice, what's the worst thing that can happen? Is you pick up the phone and you go, hello, hello, hello. And so the call takes a little time to get established, and what happens is the caller just hangs up because they didn't hear anybody else. So the session starts getting in progress, and so they're starting to already exchange and pre-establishing the call, in essence. And so the callee endpoint will send back the candidates W, X, Y, and Z, and specify that Y is the default preference. So then once it's ready to pick up, and when the caller picks up, it sends back again a 200 OK, in this case saying, I've accepted the call, and sends back those candidates. And that way, it knows which candidates, in the meantime, they can figure out which candidates work. So the caller can figure out which candidate they can use to establish a connection with the callee and vice versa. So federation. So what ports do I really need to open on federation? So that was the question to this gentleman who was saying, you know, the security team was always asking, which ports do I have to open, right? And which ones do I not need to open? And I just want to know, and they really want to have a justification as to, okay, which port, what is this port for, and what do I use it for, and all that stuff. So here's a bit of information on that. Oops. So for Lync server, and maybe I wanted to start backwards here, but for OCS 2003, you had to open a bunch of ports. You had to open port 3478 on UDP, and TCP was 443. But then you had this wide range of ports, 50,000 to 59,999. And it would have to be open on UDP and TCP. And a lot of the security folks would go, oh, that's a lot of ports. I don't want to open that many ports. You're making my security perimeter open up. It's like I might as well not even have a firewall there, right? So that was a lot of trouble. So in R2, again, 3478 was needed to be open, as well as TCP 443. But the ports 50,000 to 59,999 only needed to be open for outbound. So that meant that your edge server needed to have those ports, needs to be able to establish an outbound connection through your firewall on those ports. That meant that incoming ports incoming inbound traffic did not need to have access to it, so for R2. However, if you want to be able to do federation with a down-level client or down-level server, edge server, then you still needed to open those ports. In Lync server, we've closed that down. I mean, you only need UDP port 3478 and TCP port 443. So no additional ports are needed for remote access. And, yes, sir?
Does it also count if you want to federate with older version like OCS 2007 between Lync and OCS?
So the question is, if you want to federate between Lync and R2, for example, yeah, so then you'd need to open those ports. Yeah. And we'll go through a diagram here. But if you were only doing federation between Lync and Lync, then you would need to open it. All right. So, and I'll talk a little bit about here. So AV federation between 2007 and 2007. So here is an example. So you have 2007 edge servers, and they will need to be able to establish temporary ports basically in the range of 50,000. And so you have a UDP port and a TCP port established on the left-hand side. And similarly, you have to do the same thing on the right-hand side for the other federated. So you got two federated partners here. And then the connection would be established across those two connections, right? Those ephemeral connections, ports. So in R2, in tunnel mode, we have, in this case, R2. This is Office Communication Server 2007, R2 edge servers. Since work one here is establishing the call outbound, it goes and creates those ephemeral ports in the range of 50,000 for TCP and UDP. And the client on the right-hand side is going to do the same thing if it's going to establish. But the connection can go through UDP. And so you can see here that in work one, the ephemeral port connection in the 50,000 will connect back to TCP port 443. So it's only outbound calls that need to be opened up on those port ranges, as opposed to the 2007 case. For establishing federation between R2 and 2007 interop, so here in this case, on the left-hand side, you have an R2 edge, and on the right-hand side, you have a 2007 edge. The connection, again, here is because it's going outbound. The work one client will request the edge server to establish two ephemeral ports on the range of 50,000, a UDP port and a TCP port. And then on the work two, they'll do the same thing. In this case, because it's not backwards compatible, the UDP connection is going to attempt to go over port 3478, but that's not going to work. So then it attempts the port from the ephemeral port in the 50 range on the R2 server to TCP 443. That again will not work. So it goes and establishes across the 50K range ports. In Lync, in the case of Lync here, if you have two Lync edge servers, the connection can be established directly over port UDP 3478 and TCP port 443. So you don't have to worry about all those ephemeral connections. So if you want to have a little bit more information and kind of a bird's eye view of what's going on, you can look at the poster. And this is a snapshot of the AV and web conferencing workload. And it gives you a pretty good idea of what are the protocols you need to use, what ports you need to have open, and then what direction the initial connection is established, right? And there's a little bit of bubbles in there to give you a little bit more detail. But it gives you a nice snapshot view of all the different protocols. This is just an excerpt of the AV and web conferencing workload, but there's the other ones as well. Tips for troubleshooting AV and using the UCCP logs. So one of the things you can look for in the UCCP logs, and I won't go through that here, is you can look for AV edge provisioning, and you can search for the keyword MRAS URI for SIP 200 OK provisionings. And there's a list here of the different tips of what you can look for, like address exchange. So if you're seeing that the clients are trying to connect, but they're not able to connect, then maybe it's a problem with the candidates. They're not getting the right candidates. So if you want to maybe look at the candidates, then you can search for the keyword A equal to candidate, and that will give you, it'll bring you down to the list, to your log file, and show you the list of candidates that it was publishing, as well as the ones that it was trying to establish. So these is there to help you troubleshoot that as a help for you guys. So we do have one last giveaway here, and we also have other tracks that are available, and I want to make sure that you have these resources available. And please make sure to write up an evaluation, and you can enter to win. So the last question, actually, I'll make it simple. The first one to ask me a question wins this. Anybody? Yes, sir, you raised your hand real fast there. Do you mind standing up closer to the mic, please? That'd be great.
For Federation to Microsoft, I know you guys have recently done PIC change. What are the impacts on that? Was it just an IP role change? And are you also going to look at any port reassignments on that as well? Because I've had some recent issues with my PIC connectivity over to Microsoft as well as MSN. So I'm just wondering, has that change been done? I know it was delayed a couple of times. And is there any published information on what you're doing there?
Can you tap on it? Could you unmute his mic, please?
Okay, thanks. So the question was around what, if we did any changes. Not that I'm aware of, and if there are any problems, we can follow up with the team. We have a team that takes care of these questions. It should not have changed. I mean, we should not do any breaking changes around that. Yeah. Okay, we would have to check in to see if they have done anything. Yeah.
Usually, there's a website that they have, and they would normally publish that information.
Yeah. So by the way, I wanted to, since this came up quite a bit, is that the question, the single versus the multiple IP addresses. And I just wanted to give you like a quick overview of why this actually is. And I will put them into two pieces. The one are not real reasons to do it, and there's another one, there's real reasons to do it. So let me start with the perceived thing. So the first thing is that, yes, you have the problem with your security team that you ask to want to open this additional port, and it's like, what is going on there? And 443 usually is accepted because it's HTTPS. So it's like, oh yeah, we good with that. And of course, your surface area does not change. If you have multiple IP addresses and you just listen on a different port, the security of the component that behind is not getting better or worse if you have this on a different port. But nevertheless, we have a lot of customers that say, I don't get it through my security review, and even if I would have to do that, it's going to take me like 2 years or 6 months or something that is not acceptable. So this is not a real reason, but it is something that frequently happens. The next not so real reason is that historically, back in OCS 2007, we had an expanded edge where we had different edge servers, and we just happened to say, oh yeah, use 443 because it's a different server, has a different IP address. So once we consolidated the edge into one, we just said, well, why don't you have 3 different IP addresses to do that? So this is, again, is not a real reason. This is something that has historically happened. Okay, so now we have real reasons, and that's now it's getting interesting. So there's a really good reason to do that, and that is around your security that you have. On the SIP traffic that you have, typically the SIP traffic is not a lot, right? You get just a little bit of traffic, is not much. On the AV side, you get a lot of UDP traffic, high volume. So what you can do is, if you have a separate IP address in your router, you can monitor the traffic directly in your router, and you can basically do an SMTP trap to send if it goes over a specific threshold, because then you can assume somebody's trying to do a denial of service. You would not be able to do that with the AV because you will have a lot of traffic there. So you can monitor this port, and you can put something in place and say, hey, if this threshold is exceeded, I'm pretty sure somebody either is some, it's specifically about the federated partners, or something happens on the outside that hammers me, and I get an alert. And although we have some throttling in the edge, this is the first line of defense, would be on the router. And the last one, which is actually another pretty interesting scenario, and that is around VPN. So if you have a VPN requirement, what happens, and if you try to flow your media through your VPN, not a good idea usually, because usually it's encapsulated, the tunnel is encapsulated in TCP packets. That's one thing, so it makes the quality go down, the first item. The second item is if you have an IPsec underneath, for some reason, every now and then, the IPsec tries to renegotiate its stuff. And it does a TCP, so it just halts the whole thing, right? It's like, okay, let me get those things sorted out again, and you have a big glitch in the audio. So for example, what we do in Microsoft is we have a VPN solution that has an exception for the media relay IP address baked into the VPN. So what happens is that you can use your VPN, you can signal into your server, you bypass the edge server, but when you do the media negotiation, you will get this IP address from the edge, and it will not go through the VPN tunnel. So your media will flow directly through the edge server. And that kind of satisfies the guys that say, hey, we don't really want to have real external access. We want to use that through the VPN tunnel. So for example, we have that was the problem that we had at MSIT. And the typical scenario that we actually had was that it snowed in Seattle, and everybody worked from home. Everybody used their VPN. They used Lync, or Office Communication Server, Office Communicator, and the VPN quality just crashed. And so once we put this exemption in, we are happy now in terms of the AV performance. We will always go through the edge.
So you put the exception for the AV media traffic to go over the public IP.
Exactly. And what you can do there is you can say, hey, my SIP, don't use the edge. Go just through the tunnel and go as if you were an internal client. But when we do the media negotiation, we will still get this from the edge as a candidate, and you say, oh, use this for this type of traffic, use the public, don't use the tunnel for that. And so don't ask me exactly how this is done in the VPN client, but we have an exemption in there. Yeah. Right. I'm sorry? The Microsoft Direct Access is using this as well, but also we have also a VPN client. So the direct access was something that came recently, and it does not work all the time. So trust me, I've been all over the place, and sometimes it does not work, and then you have to fall back and use the VPN tunnel that is still available, like here. Yeah. Right. So there are some scenarios where this doesn't work, and there's also another aspect that which is it's not totally true, but if you have a really large deployment and you have a really beefy edge server, you can actually get benefit from have dedicated NICs on your edge server. Of course, if the traffic flows inside, on the other end, and you have a single NIC there, it better be like, let's say, a 10 gigabit NIC, and then if your infrastructure supports that, you can have a single 10 gigabit NIC that goes to your internal while you have multiple 1 gigabit NIC external IP addresses. Again, another argument against multiple IP addresses is the fact that you need public IP addresses, which is
Static public IP addresses.
Yeah, static public IP addresses, which you typically are very scarce, right? You pay for them, and your ISP allocates a number to them, and if you use them up, then you're out of luck usually. So. Yeah. So the question is, do we break it up? Currently, we don't plan to do that. I mean, we hope that. So for one, I mean, for you to saturate a 1 gigabit NIC, actually a lot of stuff has to flow. Looking forward, with higher quality video, higher resolution, all this type of stuff, the question for us, what do we do is, should we do NIC teaming with Lync aggregation? Is that the way to go? And then you have multiple 1 gigabit NICs that are aggregated, Or should we say, hey, is a 10 gigabit Ethernet? And we actually had this discussion in our data center because currently in our data centers, the top of rack switch is a 1 gigabit down to the machine with a team NIC. And we approached them and said, look, how about the 10 gigabit? We might need that for some server rules. And they were very, it's a huge cost difference, right? If you have a traditional top of rack with 1 gigabit, this is kind of commodity. But if you have those top of rack switches that have, the 48 ports with 10 gigabit, then you pay big bucks. So we are kind of, in our case, we said, okay, maybe we will, so each machine in our data centers have 2 top of rack switches for redundancies, they're teamed. And in the edge cases, we probably have 4 or 6 top of racks, and then we do some of the link aggregation actually. And we team them. I mean, they're currently teamed. All of them are teamed for fault tolerance, but we are looking into if we can actually team them with the load balancing, which is it's a little bit iffy because it depends on the chipset, on the driver, and on what the switch does. Yeah. Right. Yes. Correct. So there's some. So the whole discussion around the bandwidth and the NIC teaming. I mean, this is something what we've been looking at. The server gets more powerful. I mean, we will soon have, for example, the Sandy Bridge CPUs with 10 cores, and so we are hitting on the 1 gigabit limit. So we ran some perf tests internally, and at the peak, it was the application sharing actually was that killed us. At the peak, on a regular server, we hit 750 megabit per second on the app sharing traffic, right? And of course that was artificial because somebody pasted pictures into the whiteboard, right? And that caused everybody to get this refresh. And so now high definition video. There's a number of things that we're looking into, kind of the hardware boundaries basically, and I mean, even if you have the 10 gigabit, I mean, you have to have the infrastructure to move it out to your clients as well. It's just, exactly. So that's exactly the one choice that we have to do, and that's our in our data centers. They also said because I mean the cost difference is huge for those switches, right? Yes, you're aware. Yeah. The offloading NICs. So so there's a couple of. So again, this is they're HP and Dell, and they have those NICs that do some of the negotiation on the hardware offload. We haven't evaluated it fully. Again, it's the commodity thing, right? I mean, we are buying thousands of servers that are all the same, and they're Right. So we see a lot of the commodity servers now come with 4 NICs actually, versus 2. So but again, the thing is, if you are in our data centers, if you say, hey, I want this special NIC in this server, the price, because the discounts that we get, it's just all of a sudden you have something special, and just to get it approved and to actually roll it out is very hard. Right. So our goal is that we will want to run on commodity hardware, even if the our demand on the CPU power and the network goes up. We want to stick to a 2-socket 1U server that with Not yet, but think about multi-view and those type of multiple.
Or you just go with the Polycom.
Yeah. Yeah. So, exactly. Yeah.
Good.
Okay.
You had another question back there. Stick around. Congratulations. Ah.
Yes.
Oh, yes. I know you want it.
Sorry. It doesn't matter, how this DNS load balancing.
Yes,
If it's
absolutely.
round robin, that's fine with us. Or if it's randomized, that's fine with us as well.
What happens in the case where an agent wants to you were saying that if it is saying that wants to like a visit,
Yes.
when you actually have an ISP that wants to come to one edge, what happens if you switch out like you
So the problem is if you have any partner that is not aware of the DNS load balancing, so this is a problem, right? So what typically is there's a time to live on the DNS record, and if this is depending on how long you set that, usually the other side will retry and will once the cache expires on the DNS, it will retry get another IP address through the round robin or something like that, and it will reconnect. So if you have a lot of legacy with other partners or AV Federation or other things that you don't quite know what they're using, hardware load balancing is the safe route because if one of the machines go down, you don't have any delay. But the thing is, I mean, typically even if the other party is not aware of DNS load balancing and they only read the first DNSA record, they will pick one and they will randomly pick one or the other and just use this one. The problem is if it fails, if it's not available, they will retry that and they will do a DNS resolution again until the time to live is expired, and they will get another one and it will connect. So there's an outage that lives between there. So
when it keeps retrying.
yes. Let me turn this off so I don't.